Okay, this here assignment is, we kind of did this back in September, but there's some variations to the problem that I really didn't teach you guys that I know you guys will need to know how to do in trig. So number one, I'm going to go through 8 examples. That's probably a little too many, but whatever. And then you have 4 problems on the assignment. Okay, it says, number one, the manager of a store that specializes in selling tea decides to experiment with a new blend. She will mix some Earl Grey tea, that's in bold for a reason, that sells for $5 per pound, with some orange Pekoe tea that sells for $3 per pound to get 100 pounds of the new blend. If all this is sold, they'll make $450. How many pounds of each type of tea is required? So you have to find the orange Pekoe, I think I'm saying that right. You got to find how many pounds of that, and you have to find the Earl Grey, and you need to know how many pounds of that. Well, you can see there's 3 units. You got the Earl Grey tea, the orange Pekoe tea, and then the money, okay? So, we remember 3 units, we want to make this table. It's like the tic-tac-toe table. And remember how to label this. You put together, and then always how many, per, and total. So you got Earl Grey and orange Pekoe. Those are the 2 types of tea. You label those, and then you have the dollars per and the dollars total. So your dollars total, you know you have $450. Now come up here first, okay? And then this is not money related, okay? This is not how many units, okay? It has nothing to do with money. So the only number in this problem that has nothing to do with money is the 100. And it says 100 of the new blend. Well, that's sent together, okay? And then label that X and that Y, because those are the answers to the problem, okay? All right, now if you have a number here, you don't need anything here. If you have a number here. Okay, then the Earl Grey tea's $5 per, and then $3 per, and that's going to be 5x and 3y. So you have that equation and this equation, which makes a system of equations. So you have x plus y equals 100, and then you have 5x plus 3y equals 450. Okay. And then you need to use elimination. You have 5 here, so we want to multiply the top equation all by 5 and the bottom by 1. You guys should remember this. Okay, so you have 5x plus 5y equals 500, and then 5x plus 3y equals 450, because you're just timesing it by 1. So negative, 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 then those cancel. 5 and negative 3 make 2y. And then 500 and negative 450 make 50. So then we divide by 2, and y is 25. Okay, so y is the orange Pekoe. So we have 25 pounds of that. Now you could put 25 in for y here. You could also use some common sense. Together you have 100. You have 25 of the orange Pekoe. We could take 100 minus 25, and that would be 75. So 25 pounds of orange Pekoe and 75 pounds of Earl Grey. Now, some of you are like, well, what's the point of that? Why are you doing that? Well, now the game's going to change on the next problems. A coffee manufacturer sells cinnamon coffee for $7 per pound and vanilla coffee for $10 per pound. At the end of the month, the cinnamon coffee had 30 pounds remaining. The store manager decides to mix these 30 pounds with the vanilla coffee. Okay? Actually, I'm going to mix these pounds with the vanilla coffee. He sells a mixture for $8.50 per pound. How many pounds of vanilla coffee should be mixed to ensure no change in revenue? So we're finding just how many pounds of vanilla coffee. Now there's cinnamon coffee, but we already know how many pounds that has. That has 30. So vanilla pounds. So you're going to reset up that table, but now something's going to happen you haven't seen before. Okay? So you have together, and then how many per and total. Dollar. Okay, so you have cinnamon and vanilla. Now find me a non-money number. okay? The only non-money number you have is 30 pounds. And read the problem. The cinnamon coffee had 30 pounds remaining. So the cinnamon 30 goes here this time because it says that specifies that cinnamon. 30 pounds, okay? Now we don't know the vanilla, so X. Now you can put something here. Here's what you're going to put. You're going to put X plus 30 because you'd add those two together. Put it in parentheses. Okay, now the dollars per, well, you have $3 per. You got the cinnamon for $7 per pound. You have the vanilla for $10 per pound, but then you're going to mix it together, and you're going to mix it, and that's $8.50 per pound. Okay, so when you mix the blends together, then a pound is going to sell for $8.50. Okay. Now, that's pretty much everything, okay? We don't have anything to put in this bottom, so we got to multiply. We take 30 times 7, and that's 210. And the equals goes here. X times 10 is 10x. And then here you apply the distributive property, okay? You are timesing. So x times 850 is 850x, and we got to take 850 times 30. 255. So now write the equation. It's a different looking. You got 210 plus 10x, because that would be the money total if you sold them separately, if you never mixed them together. Okay, because you have 30 pounds of cinnamon times 7, X pounds of vanilla times 10. But then when you mix them together, you want that to you want no change in revenue. That means you want the separates to equal the together. So equals 850x plus 255, okay? Then you'd have to subtract your 850x from your 10x. So it's 1.50x plus 210 equals 255. So I subtract 210. That's 45. Then I divide by $1.50. And that's going to be 30, okay? 30 pounds. Now, it's not always the same. So 30-30 mix. Yeah, that one they were the same, but it doesn't always come out that way. Just know that. Okay, number 3. Now, the game really changes. You're going to use a table. I have $30,000 to invest in 2 things: savings bonds and certificates of deposits. Savings bonds pay 5% interest, while certificates of deposit pay 7% interest. I want to earn exactly $1,760 in interest. How much should I invest in each? What you have is a mixture of 2%, 5% and 7%. So you're going to make the table, because these are the answers. You want how much money into the 5% interest, and how much money into the 7% interest. Make your table, but you're going to label this table differently. You're not going to do the how many per in total. Here's what you do on the top. You put your low percent first, 5%, your high percent next, 7%, and then if there's a third percent in the middle, you put it here, but if there's not one, you put together. Okay? So that's how you're going to label that. Now, all you're going to label here is a percent sign. And you're going to put the label in the problem, which is just dollars. Okay, you can see down here dollars. Okay, now fill out your percent first. Okay, 5% you need to write as a decimal. 5% is 0.05. 7%, 0.07, and then together, well, we don't have a third percent, so you put NA or just scribble the box out. Doesn't matter, okay? All right, now, find me the 2 money numbers, okay? $30,000 and $1,760. Now, they're both together, but you got to know which one to put where, because it matters. The high amount, $30,000, goes up here, okay? The high amount. And then we have X and we have Y. Then the low amount, after I take 5% of this and 7% of this, That's the interest, okay? So you want it, when you're doing these decimals, you put the high here and the low here, okay? And then goes from there. You multiply this by this, because 5% of x plus 7% of y equals the interest I get. Okay, so what you put in, what you start with goes here, and then what you end up with when the interest rates goes here. Now, you can see how this is going to play out, because you have x plus y equals 30,000. Now, I'm not a fan of decimals on this. What you're going to do is times all of these by 100, and then the decimals go away. Then this will become 5x, because 0.05 times 100 is 5, plus 7y, and then I need to multiply that third one by 100. You don't just leave it. It's you get rid of the decimals. 176,000. Okay, then 5, 5, 5, 1, 1, 1. So you're going to have 5x plus 5y. 30,000 times 5 is 150,000. And the bottom just stays the same. You see, now I don't have to worry about those dumb decimals getting in the way and screwing up stuff. Negative, negative. So that's negative 2y. If I add those, it's going to be negative 26,000. And if I divide the negative by the negative, it's going to be 13,000. So the y is 13,000. So you got $13,000 at 7%. Okay, then to find the x, the 5%, you can just subtract these. 30,000 minus 13,000, and that's 17,000. $17,000. Answer, problem solved. You can always check your answer by taking 5% times 17,000 plus 7%, 0.07 times 13,000, and that should give you 1760. Yep. Okay, number 4. Number 4 is kind of like number 3. There is a change though. In a chemistry class, you have a combination of 1% of hydrochloric acid solution, 5% hydrochloric acid solution. You need 100 milliliters of a 3% hydrochloric acid solution. How much of each solution should you pour into the mix? So you want 1% and you want 5%. Okay. So make your chart. Okay, so put your lowest percent here. Put your highest percent, 5% here. These two things should cover this. And then put together, but you have a third percent, and that's 3%. So that together, put 3% above that, please. Okay? Last problem, we didn't have a percent to go together. Now we do. So put percent and milliliters. Okay? So let's talk about our percent, 0.01, 0.05. Don't put that as NA because we now have a percent, which we're going to write as 0.03. Now the only milliliters I really have is 100, okay? And if that's the only one I have, we're going to put that right here, okay? Because together of the 3%, they need 100 milliliters of it, okay? That's X, that's Y. So you multiply that 0.01x, multiply that 0.05y. And you need to multiply these two because you're not given the milliliters. By the way, this here represents up top the x plus y equals 100. That just means how many milliliters of the entire thing you have. This is just the milliliters of the hydrochloric acid down here, okay? So milliliters here, and this is the milliliters of the hydrochloric acid. Because 1% of this is hydrochloric acid, 5% of that. So how much together is hydrochloric acid? Well, we're going to times those two. So 100 times 0.033. Okay, and you have your two equations. It's like the interest problem. It's just science. It's just chemistry now. So the whole solution, x milliliters plus y milliliters, 100. Now, times these by 100. So then the decimals go away. So that'll be 1x plus 5y equals 300, remember, times that, okay? Okay, you don't have to multiply because you go negative, and then that goes away. So add those, you get negative 4y. Add those, you get negative 200. Then divide by negative 4, and you get 50. So you have 50 milliliters of the 5%. And then minus 50 from that, and then it'd be 50 on that one. They're not always 50-50 or the same, okay, but 50 milliliters, 50 milliliters, okay? Because 50 and 50 makes 100. Now for the hydrochloric acid, if I take 1% of the 50 plus 5% of the 50, that should equal 3. Yep. So there we have it. Okay, now I'm going to go over another round of them. Okay. So number 5, in a week, a music store sold 9 guitars for $3,611. Electric guitars sold for $479 each. Acoustic guitars sold for $339 each. How many type of each guitar were sold? So you got electric and acoustic. We're not dealing with percent, so we go back to the old school with the how many per and total. So we're electric, acoustic, and together. Okay. Okay, so find me a number without the money. Okay, well, the money amount, we just have 9. It says 9 guitars, so that must be together. So now cost per electric are $479. How much is one? Or no, yeah, acoustics $339, and we're not really putting them together, so that goes away. Now the total amount together we know is 3,611. Okay, and that's going to be 479x, 339y, and then we have our two equations. Now you don't have decimals, so don't multiply by 100. You're going to have x plus y equals 9. 479x plus 339y equals 3611. So 479, 479, 479. So you have 479x plus 479y. 9 times 479 is 4,311, and the bottom would just remain the same. When you multiply by 1, it's just the same. So negative, 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 add 140y, and then 700. Divide by 140, and y is 5. So the acoustics, we know there's 5 of them. Well, if there's 9 altogether, 9 minus 5 is 4. Okay. Number 6. Again, that problem right there, example 1, example 5, we already knew how to do that. Okay. Number 6, a candy store sells Reese's peanut butter cups at $3 per pound, M&Ms at $5 per pound. At the end of the month, the manager has 20 pounds of M&Ms left. He wants to get these sold, so he mixes them with Reese's and sells the mix for $3.50 per pound. How many pounds of Reese's cups does he need to put in the mix to ensure he will make the same amount of money as if it were sold separately? So we're finding how many Reese's he has. That's the only thing we have to find. We don't need to find the M&Ms. We already know the pounds we have of those. We have 20 pounds. So line up the table. It's just going to look a little different. Together, how many per dollars per total? Okay, so Reese's and M&Ms. Okay. Now, find me the non-money amounts. That's your best bet, is to start up here. Okay, so you have 20 pounds, but it's not together, it's of the M&Ms. So unlike the last problem, we have 20 pounds of M&Ms. Reese's we don't know. And then over here I can write the expression x plus 20. Okay, put it in parentheses. Now dollars per, now the Reese's, $3 per pound. And that'll give me 3x down here. The M&Ms, we know that's $5 per pound, and then 20 times 5 is 100. And then we are mixing them together. So when we're mixing the M&Ms and the Reese's together, the cost per is $3.50 per pound. Okay, and then I apply the distributive property. You multiply. Okay, so that's 3.50x, and then 3.50 times 20 is 70. And now you have an equation you can work with. So 3x plus 100 equals 3.50x plus 70. Okay, so minus your smaller x. Oh, I just totally screwed something up. Okay, minus 3x on my computer. So 100 equals 0.50x plus 70. And then you minus 70. That's 30. So 30 equals 0.50 times x divided by 0.50. And 30 divided by 0.50 is 60. So 60 equals x. So you have 60 pounds of Reese's. Just a second, I can get signed back into my computer. Okay, now example 7. A person has $50,000 to invest in 2 accounts. One account pays 11% interest, the second pays 8% interest. If the person earns $4,810 in interest, how much money was invested in each? So we got to find the money that was invested in the 11% and the money that was invested in the 8%. So that table's going up. You're going to use it when you have a mixture of percents, which we haven't done this year. You put your lowest percent here, then your highest percent, and then write together. Now, is there a third percent? On this one, there is not. Okay, just the 8 and the 11. Okay, so the two answers go here, lower, higher, together. Okay, so percent, and then put dollars. Okay. Okay, so 0.08, 0.11. And then there is no percent here, so put NA or just scribble it out. Okay. Now give me a dollars. Now there's $2 amounts. The higher amount before the percents are applied, you always put the higher one up here, and then X and Y. So we know that times that is 0.08X, 0.11Y. Now you don't have anything to times this by, so you better have a dollar amount for your percents, which you do. You have the 4,810. Okay, and you got your system. X plus Y equals 50,000. And then multiply that by 100 so those decimals go away. We don't want those. Okay, so 8X plus 11Y. And this times 100 is just 2 more zeros on 481000, and then times by 8 on top and 1 on the bottom. So 8x plus 8y. 50,000 times 8 is 400,000. I think it's right anyway. Okay. Yep, 400,000. Bottom remains the same. $481,000. Then negative, negative, negative. So that's negative 3y. This is going to be negative 81,000. Use a calculator to add them if you're not sure. That's $27,000. Okay. So the Y up there is 27 grand. Okay, so the 11%, 27,000. Then the second answer, you can just minus 50,000 minus 27,000, and that's 23,000. Okay, there you have it. Okay, last one, number 8. A chemist has a combination of 12% acid solution and 20% acid solution. He needs 300 milliliters of an 18% acid solution. How many milliliters of each solution should he use? Okay, so we got to find the 12% and the 20%. milliliters, milliliters. So again, this is a percent table, okay? Not the how many per and single. So put the two answers you want to find. You want to find the 12% and the 20%, and then put together, but you have a third percent that you can express together, and that would be the 18, okay? Okay, then you put percent and you put ml. So do your percents first, 0.12, 0.20, and we don't put NA, we put 0.18, 18%. Okay, so the milliliters together, okay? Well, the only milliliters I have is 300, and that's what the 18% says it is, okay? It needs 300 milliliters of an 18%, so that would be together. And then X and Y. So that's going to be 0.12X, 0.20Y, and then times these two. To figure out what goes there, you need to multiply them. Just like you did here. This times this, this times this, this times this. So 300 times 0.18 is 54. And you have your two equations, the system. Okay. We know that the overall milliliters states that X plus Y equals 300. Now, the part that's acid, 12% of this is acid. Okay. 20% of that is acid. Or no, times by 100, I'm sorry. I'm just explaining. 12% of the X is acid, 20% of the Y container is acid, and then when you mix them to put them together, you'll have 54 gallons of acid. Now we're going to multiply them by 100, so it's 12X plus 20Y equals 5,400. Okay, so multiply these by 12 and these by 1. So we have 12X plus 12Y equals 3,600. And then the bottom, it stays the same. 12X plus 20Y equals 5,400. So negative, negative, negative. So 12 plus negative 20 is negative 8Y. Add those. I think that's negative 1,800. Divide by negative 8. $2.25. So Y is $2.25. So we're going to have 225 gallons of the 20%. Okay, and then take your 300 minus 225, and that's 75. Now, it makes sense that we have more gallons of the 20% because 18% is closer to 20 than it is to 12. Okay, so there you have it. So that's the gallons, or the milliliters. That's the overall milliliters. So if we take 12% times 75 and add 20% of 225, that should come out to 54. Okay, which it does.